Alright, here we have a circular motion problem. In the circular motion problem, we've got a 5 kilogram ball or object on a 1.5 meter long string. And we're swinging it around horizontally. That's important. If it was vertical, if it was going up and down like this, we'd have to worry about gravity. And we're not dealing with that. Now we have the tension on the string's maximum value is 300 newtons. Okay? So the question is, what is the minimum time for one revolution? Now the minimum time is going to be when it's moving the fastest. Okay? So we want to maximize our velocity. Alright? Now we know from centripetal acceleration that A equals v squared over r. We also know, of course, that F equals ma, so we should get that the centripetal force is equal to mass velocity squared over r. We know our mass, we know our maximum tension. Because the tension is going to be equal to the centripetal force. And the reason is because all of the centripetal force is going to be being applied by that tension. So we get 300 equals 1.5, oopsie, not 1.5, that's the radius, 5 v squared over r, which is 1.5. Okay, we solve that out, we should get a velocity of 9.49 meters per second. That tells us the maximum velocity we can swing this at. But that doesn't tell us the final answer. We want to know what is the minimum time for one revolution. Well, to get time, we usually want velocity equals distance over time. So we know velocity, we need to find distance. Now we want the distance of what? One revolution. Okay, so that's going to be the circumference of the circle. So our distance is going to equal 2 pi r, or 9.42. Okay? Take this, we get time equals distance over velocity equals 9.42 over 9.49. And our time comes out to be 0.99 seconds. Alright? Now, how would this be different if we had to deal with gravity? Okay? What we have to do is we have to take away some of the tension as the force of gravity. Okay? When this object was at the bottom of its turn, if it was going around like this, the tension, the gravity, so if I was just hanging on a string in there without any spin at all, so no acceleration, the gravitational force would be 49 newtons, right? 5, the mass, times gravity. And so we'd have to take that into account as part of the tension. Alright? So there it is. Awesome.